Welcome to Khetz Tutorials, and in this video, I'll be talking about symmetrical and skewed data. To fully understand what this means, then we have to break down each of them. So let's talk about each of these. In simple terms, when we say something is symmetrical, let's say we have a shape and we divide it somewhere there. We are currently assuming that that is the middle section, or that would produce equal sections on either side. So this has been cut symmetrically, and we can talk about the axis of symmetry and stuff like that. So when we talk about symmetry, and when we say something is symmetrical, it is made up of equal sides. So we basically cut it or dissected it or bisected it, which is the correct term for dividing something in two, and those two portions are actually equal. Now, if something is skewed, then it's slightly off. If we have the same shape and we cut it, maybe perhaps at that point, this side is smaller than this side. And this is skewed if we were to look at either side with respect to the dividing line over there. So the same applies in statistics. We have a line which we use to determine whether our data is symmetrical, which means the data on this side and the data on this side is equal, or we can have this line somewhere there where we have less data on this side and more data on that side, and that is when we talk about skewed data. So that is the overall explanation of what all of this is all about. Now, using specific terms which are specific to statistics, then let's start our discussion. Now, this middle line that you look at, or the middle line that I was talking about, would be your median. So this is the median. From the previous videos, you should know how to find the median by now. Now, if the mean, and the mean is, so let's talk about the mean before we continue. Now, this mean is the average. And in a class, if you have certain marks, and the average, let's say the average of your class is 60. Now, that means that most people got at least 60 or above, or if you sum up everything and divide by the total number of people, then this gives you an idea of where the marks fall or what the majority of the people got. Now, if the mean equals the median, then you have symmetrical data. So there are basically some people on this side and there are some other people on this side. And since the mean is a description of the overall test or the sample or whatever group was taken out, then we say that this is a normal distribution. And the normal distribution is associated with symmetry. So we're saying that this distribution is symmetrical. And that is when the mean is equal to the median. So that is how you check. You check your mean, you calculate your mean, and that was also covered in a previous video. Then you'd calculate or you'd get your median, and that was also calculated or shown in a previous video. After getting these two values, if they are equal, then you know that you have a normal distribution, or the data is evenly distributed and it's therefore symmetrical. Now, if you have a case where your mean is greater, so let's say the mean, you calculate your mean and it falls somewhere there, and you have your median somewhere there. Now, we say that this data is right skewed. So this is right skewed. So once again, this is with respect to your median and your mean. Now, if you see that the point that you get in the middle of your data set is less than the average, which is the overall percentage, then your data is right skewed. And this applies in the opposite direction. If you have your mean, which is the average of the overall data, if you have it less than the median, so in this case we have the mean greater than the median, that would give you right skewed data. And if you have your mean less than your median, then your data is left skewed. And you can always look at this from your box and whisker, which are also covered. So after finding your 5-number summary, so the 5-number summary, after getting this, and I just link the video to the 5-number summary, you can then find your Q2, which is the median. So this is the median, and from the previous video, or from the basic calculation of your mean, of the average, you can find the mean. What you have to do is to compare these two. Now, after comparing these two, you can then tell whether your mean is greater or less than your median. And if it's greater than the median, then your data is right skewed. If it's less than the median, then you have left skewed data. And if the median and the mean are equal, then you have a normal distribution, which is also called symmetrical data. So that is all with regards to distribution and how you identify this kind of stuff. And usually the box and whisker for each of these would look like this. So you expect your Q2 to be right in the middle of your Q1 and Q3 for normal distribution, which is for symmetrical data. So this is symmetrical data. And you expect your Q2 to be, which is the median, because for right, let's talk about right skewed. So right skewed, you have your mean greater than your median, which means your median is essentially small. So expect it to fall somewhere on this side, right? And this is for your right skewed. And finally, if your Q2 inches more towards the Q3, then this is an indication that you have your median. So the median is actually greater than the mean, or the mean is less than the median. And in this case, you'd have left skewed. So I remember there's a trick which I used when I used to do this back in the day. It wasn't that long ago, but let me just say back in the day, when I used to look at this stuff, what I'd do is I'd look at my Q2. Now, if the Q2 is to the left, then I'd immediately conclude that it's right skewed. And if it's on the right, I'd immediately conclude that it's left skewed. So I'd invert what I see from my box and whisker to actually determine whether the data is right skewed or left skewed. And that is how I did it. That was my shortcut to working out this stuff. But I haven't really seen a case where this shortcut fails. So just stick to the theory, or just make sure that these things hold. And if you're satisfied, then you can also use the shortcut. So that is just a shortcut, I guess, which you can use. And this one, there isn't any shortcut. You just see that Q2 equals the mean, and you have symmetrical data. Another thing that I want to talk about in this video is outliers. So outliers. Now imagine in a class we have someone who got 80 and the rest of the people got, let's say, 78. Let's talk about 5 people for now. 75, and someone got 70, then there's a person who got 20. Now, if you look at this data set, you can see that this is much, much smaller than all of these other ones. And in a case where you have people who got 60, 50, 55, 47, and let's say someone got 100, you can see that this stands out. So outliers are numbers which stand out, basically stand out, numbers which stand out. Now, it's not always advisable to just look at your data set and pick any value which looks out of place. So it's not always simple to identify your outliers just by looking at your data set. So there's a mathematical rule, or there's a mathematical way that you can actually find your outliers. So your outlier would be any number which is less than Q1 subtract 1.5 multiplied by your interquartile range. And all of this, the Q1 is associated with a 5-number summary, which I'll link if you haven't watched that, or if you don't know how to calculate that. And your interquartile range is just Q3 subtract Q1. and your Q1 is just your Q1 from the 5-number summary. So if you have this and that, and you compute this, this will be your lower bound. And if there is any number which is less than this lower bound, so let's say we have this lower bound, let's say LB for lower bound, which would be the result of that. Now, if anything falls to the left of this, which means if anything is less than this lower bound, then you have an outlier. We also have an upper bound, and therefore we talk about this other direction. If any number in the data set is greater than Q3, which is all the way on the other side, but now we add plus 1.5 multiplied by your same interquartile range. So just replace the Q1 with the Q3, replace that with the positive, then do the same multiplication over there. Let's call this the upper bound, UB. So this is the upper bound. Upper bound. So anything which falls between your lower bound and your upper bound is perfectly fine. That is why I use the color green. And anything to the left, or anything which is lower than this lower bound, and anything which is greater than this upper bound is an outlier. So at this point, I do expect that you know how to find your 5-number summary. And after finding a 5-number summary, we just have to substitute those values here. And this 1.5 has basically just been set there, just take it as it is. And that is how you'd find your lower bound and your upper bound. As long as your data is between the upper bound and your lower bound, then it's fine. But once it steps outside, either less than the lower bound or greater than the upper bound, then you know that you have an outlier. So in this video, we talked about symmetrical data, skewed data, as well as outliers. I hope you found it as content of value. I hope it cleared anything that you might have had doubts about. And if you have anything to say, any comments, leave a comment, send me an email. If you want to book a session with me, private sessions, you can also email me. If you like the video, give it a thumbs up. If you haven't subscribed, please subscribe, and I will see you in the next video.